dear viewers and students. Today's in this session we have to look about projection of straight lines. In previous we are looked about projection of points and theory of projection. Now, so what do you mean by straight line? A straight line may be generated by a point moving in one directions, or a straight line may be also defined as the shortest distance to connect between 2 points, or a straight line may be located in either space or in specifying in 2 endpoints. So, that is the concept in generation of straight lines. But what about in projection? So, in projection we are looking in different views. Already I stated in previous sessions, just we are saying about projection as a view about in front or back or right or left, top or bottom. So, that is the concept in projections. So, here the 2 view projection of straight lines. So, only we are looking about 2 views, either front and top, 3 views. So, end elevation also, that is end elevation means side views. So, and also how to determine the true length, because in projection from the true objects we are just projected onto the plane, then we are stated as projection. But how to determine if you have any projected part, because in nature of in science, so many object by looking as in projection. So, how to transfer and determine that true object or true points. So, that is the concept to determine the true length and the true inclinations. Then traces of a line. So, while you stretch or increasing the length of the lines, or it to be tracing along the path of line, it will touch either any reference planes like a horizontal plane or vertical plane, then we are say as a horizontal trace or vertical trace. So, then location of a point on a line. So, that is the concept in straight lines, how we are projected and so on. Now, we are looking about 2 view projections of straight lines. In 2 view projections, so what about these listed points? Parallel to both planes, perpendicular to one plane. So, what is the concept? Because if you take any straight line, that straight line may be parallel, that straight line parallel, not maybe, parallel. So, parallel to vertical plane as well as horizontal plane. So, what do you mean by parallel? So, the distance between the reference and the object from one point to another point, that distance not change, that is dimension not change, that is a concept of parallel. So, here both planes means vertical plane as well as horizontal plane, both plane, that line is not varying, that is the end point to the other end points, it is same dimensions. So, that is the concept. Then perpendicular to one plane, because we are put a straight line vertical, that is perpendicular to horizontal plane. So, we cannot say it is vertical on vertical plane, because it is perpendicular to vertical plane, that is then inclined. So, now we are looking about in animations, what about parallel to both planes? Here in right hand side for me in the screen left hand sides. So, try to look at the animations. Line is parallel to both planes, vertical plane as well as horizontal plane, by tracing, that is projected visual rays. So, already I said projectors. So, that projectors projecting onto the plane, then it trace and put it as in single paper. So, then we are looking about above the reference lines. Already I stated reference line is nothing but a line of intersection of 2 reference planes. So, that is horizontal plane and vertical plane intersect to each other, that is in straight line, that is a reference line. So, above the reference line what we say? So, normally elevation or any type of views projected onto the screen, that is we are talking about here as a projection. But according to first angle projection, second angle, third angle and fourth angle we are stated. But so how to say? If any elevation is above the reference line and plan below the reference line. That particular is first angle projection. If it is ulta, that is opposite. So, top view or plan view above the reference line. So, elevation or front view below the reference line, that is third angle projection. The remaining two it not help because overlapping, due to overlapping, that is why I already stated in theory of projection. So, due to overlapping in second angle projection and fourth angle projection, we are avoided. So, only we are using first angle and third angle projections. So, some country they are following third angle projection, some other, but even in our India, in manufacturing they are using first angle, but in civil and other types of construction work they are following third angle projection. Yeah, here the above A dash and B dash, this is also I already stated. So, how to give a number, how to give a lettering. So, if you pronounce capital letters for any endpoints of the object, that denotes true points of the true object or original object. Yeah, if you are placing any small letter, that is lower case, but in dash, A dash, B dash, so that represent elevation, front view, side elevation. So, for side elevation double dash also we have to use, but here A dash, B dash, so that this represents elevation. So, A and B represent plan view. So, here it stated above and below. So, this is first angle projections. So, this is a line parallel to both, a line parallel to both planes, that is vertical plane as well as horizontal plane. Straight line perpendicular to the planes. So, you have to put, yeah, that is why in that animation, in look at these animations, in this animation, so perpendicular to horizontal plane, the above, that is top of the animation shows, so a line perpendicular to horizontal plane. So, below animation shows a vertical line perpendicular to, that is vertical, that is not vertical line, a line perpendicular to vertical plane. So, both. So, how it look in front of and top of. So, that is, yeah, finally, while you projected, because what I am stated in the previous sessions, projection nothing but showing of views, different views. There are 6 numbers of views are there to represent an object in a plain paper. So, by representing the minimum 2 views above and below of referencing line, that is projection, that is I stated earlier. So, here while you placing the line, so perpendicular to horizontal plane and perpendicular to vertical plane, then how it projected. So, if you looking in front of, if it is say for example line perpendicular to horizontal plane, if you looking in front of, so we are able to observe the true length of a line. So, that should be projected onto the above reference line, that is elevation A dash, B dash. If you looking from top, so what that straight line we are represent as a dot. It is a dot because already I stated in earlier definitions, a straight line is a continuous point tracing. So, while you looking from top, it is a points. So, that points is looking below. So, both endpoints are in single point, that is A comma B, because A dash, B dash, yeah, here A dash is upper because that is visible, that is why A comma B. Yeah, similarly for if you placing in vertical plane, a line perpendicular to vertical plane, how it represents. So, this animation shows clearly to you how it to be represents. Yeah, here straight line inclined to one plane parallel to other plane. So, what the concept? Yeah, here also I is giving animation. So, what is this animation stated? Yeah, 2 animation is there, is it top and bottom. So, top animation, yeah, it is inclined to horizontal plane parallel to vertical plane. So, what is the representation parallel to? Because parallel to means the distance between vertical plane and endpoints not varying, it is throughout same, the dimensions throughout same, the distance, okay, not size, the location, that is distance is same. from the vertical plane to the straight line. That is the concept. But if you are looking from horizontal plane, from one point to another point, the distance between plane and object is varying. That is inclined to HP, parallel to VP here. In bottom animations, again I go back and come next. Try to see in the bottom animations. So, it is inclined to vertical plane. So, that is the concept here given. Yeah, bottom is parallel to the bottom animation, parallel to vertical plane, the top animation, so parallel to horizontal plane. That's why, because while looking from top, so what about the concept? The top animation shows by looking top. So, from point A to B, the distance from reference line to that object is varying. So, it is inclined to vertical plane. In bottom, above reference plane, it is varying, it is inclined to horizontal plane. So, that is the concept. So, where it to parallel, where it to incline, so how to trace. Okay. Yeah, inclined to both planes, we know that. So, what about inclined to both planes? Because, so in this we cannot observe the true points either in front view or top view. Then we go for any other such views as right view or left view or some other views, because totally 6 views are there. So, by use of any one of the views, you have to obtain and transfer, or you have to placing as in true, then we have to shift it. That is the concept in projection. Then how to find out the true lengths? Yeah. So, 3 view projection of straight lines, that is why I said it now, because if it is inclined to both, we cannot observe any true points or length, then we are needed another views, that is 3 view projection. So, true length and true inclination. What is true length? Yeah, say for example, suppose the projection is given, from that we have to find out true length, and what is inclination from horizontal plane and from vertical plane, that is the concept. Try to see what about this. Yeah, there are 3 methods, but normally we are using 2 methods. That auxiliary plane method we are not using, because it is tedious, because we are using some other plane to brought those views onto that and tilt again brought it into the original. So, it will take some more time. So, that is why the last third method is not help to us. The first 2 methods, in first 2 methods both are help, but sometimes you are need to use rotating line method, some other times a rotating trapezoidal plane method, but actually here rotating not prompt word, but even though we are need to give rotating means we have to shift it. So, that is the statement given here. Actually we are named as trapezoidal plane method, trapezium area method. So, actually these methods is different. I say how it is. Rotating line methods, I have it animation for this, that is why I am showing. So, how we are saying a rotating line, because we are having a straight line, is it? That straight line is not showing true length. So, that is apparent, because true length exact dimension, but if not in same as true length, then it is apparent length. From the apparent length, how to determine true length? So, then you have to rotate the line. So, after rotating, then trace, then it shows. So, try to see now the animations. Yeah, in these animations, so there is a projection. So, in that projection again we are come to back. So, in this back, then we are following, try to see the animation. Yeah, in that animation we are able to understand what it is. Yeah, from A dash B dash, rotate that line parallel to that. So, after that shifting to another views. So, in that view we are marking and trace true length from one view to another view by rotating the line, because we are shift the line, we are shift the inclined or apparent line to parallel. So, that parallel is shifted to other views, because we are bringing that views from other views only, that is the concept. So, that is why we are shifting. So, suppose, because here concept is very important. So, what about angle of inclination? So, which angle is that? Either it is with respect to HP or with respect to VP, on what angle we have to make, that is the concept here. Try to look the animations here now. So, that is capital A, capital B, you are tracing. Afterwards, then rotate the plan view and come to elevation, then trace that point, that is AB. Then you have to refer. So, what about the angle? So, which angle is this? Here the inclination about VP is above the true length. So, that is concept. In open board I change here. In here we draw a line. Okay. Now, we have to see about reference line. I have to thin this line. This is XY, XY reference line. So, here we have to draw about plane. So, we have to draw plane. Plane. So, this is a horizontal plane, we have to draw in this back side. Then vertical plane. And below. Just for reference I drawn this, but it not exactly vertical. So, for reference I draw horizontal plane, this is horizontal plane, this one vertical plane. So, here. So, what is our aim? A line. So, I change the color as blue and I make it some line here, straight line. So, it is inclined to both, I just make it inclined to both horizontal plane as well as vertical plane. But what about the trapezium? What is the concept of trapezium? From here I shifting to red color. Trapezium. This is one end point, this is another end point. So, this is capital A, capital B. What is the meaning of capital? Uppercase, true point, true location. This is true location. Suppose if you identify any lowercase or small letters, A dash or B dash, A or B, those are defined different views, that is on projections. This is true objects, true points A and B. From that A and B, we have to trace by looking top. By looking top, we have to trace onto this. We have to trace onto this. So, this is A, B, because by looking top, by looking from top, we are able to project the two endpoints A and B onto the horizontal plane, that is small a, small b, that joining, shortest distance join, straight line. So, that is the concept, that is the concept here. So, similarly on vertical plane, by looking from here, by looking from this, by looking from here. So, then we are stated about this is A dash, this one is B dash, then line join this, line join A dash B dash, line joining of these two, that is apparent line. So, it is elevation A dash B dash. So, this is the concept actually we are have in theory of projection, but what is the concept, how to determine the true length, try to see. I just shaded by green color roughly. Okay. So, what about this area, try to see this area, because this area, what about capital A, capital B, true length. So, small a dash b dash, that is apparent, it shows elevation projected on to the plane, that is the concept. But by looking the true object or true straight lines, then we are projected onto the plane, but reverse from the plane how to. Yeah, what about the distance between B dash and capital B, the concept B dash and capital B distance, what this, where it looks, that is the concept, where it looks B dash and capital B, where it, by looking top, if you look from top, we are able to observe B dash and capital B. Similarly, A dash capital A, similarly, so A dash capital A, the distance from true point to apparent point by looking top. So, what about the inclination? So, this inclination with respect to which if you extend, so what about the inclination of this plane to this line? What about this? It is inclined to vertical plane. So, now we are able to determine apparent inclination, true inclination, because apparent inclination for projection. So, true inclination for true object. Yeah, here the inclination between the planes and true length true. So, here we are determined as theta beta. So, this is vertical plane, so beta, we are represent beta. So, this is we represent beta here, that is the concept we are following. So, beta. So, where we observe the beta, which true length this is, if you are make it any area of trapezium from A dash B dash, So, how to obtain the distance B dash and capital B, A dash and capital A, by looking top, that is if you mark any perpendicular line, try to see. So, if you draw any perpendicular line, because this is perpendicular line from A dash, that is a line A dash and capital A is perpendicular to A dash B dash. So, a line B dash capital B is perpendicular to A dash B dash. So, that is why if you know the projection, so on that projection draw a perpendicular line, measure. If you draw perpendicular line on A dash B dash, then we are measured from plan view. So, if you draw the perpendicular line in plan view, you measure the distance from elevation, that is the concept here. So, what about the angle of inclination? True inclination. So, beta represent, so the inclination between A dash and B dash, that is true length beta. Yeah, in similar case try to look this, I just shifted to yellow color and try to see this, I think it not clear. So, then I go for green color. Okay. I try to see, it is also covered by area, this is also area. So, it is also looking like a trapezium, that is trapezoidal method, we are named as a trapezoidal. So, what about here, where you look this trapezium in front of, where we look in front of. So, from a line AB, in similar case from line AB, okay, from line AB draw a perpendicular line. Then, so what about the distance? So, A capital A, so B capital B, these two, you have to obtain the perpendicular distance and mark as in perpendicular, then we have to determine true length. So, what about the inclination? What about this inclination with respect to plane? Theta. The true inclination is theta and beta. So, theta is nothing but true inclination with respect to horizontal plane, beta is nothing but true inclination with respect to vertical plane. So, where it to define, that is the concept. Yeah, just I said. So, what about this? Yeah, we are looking in problems. So, how it to be differ, how to drawn. But rotating methods, I shown that also. I shown is it in animation how the rotating methods looks. Yeah, here. So, you have to take any one endpoint. Now, I am explaining about rotating line methods. So, you have to take any one end, just I switch over the colors, red colors. So, you have to take any one end as fixed, it not change. So, try to rotate the other endpoints parallel to. So, parallel to which one? Yeah, here. So, you have to make it parallel. So, that is the concept, you have to rotate here parallel to horizontal plane. So, this is parallel to. So, where it observe by looking in front, it is transferred to this here, transfer to that. So, after transferring, then you have to extend, that is true object. So, that is the concept, try to see, because why I am telling. So, where theta and beta appear, where theta and beta appear, either it is below or above. So, theta represents A and B. So, beta represents A dash B dash with respect to, but in rotating line methods, yeah, you have to rotate this and shift it to that. So, that is inclined. So, that is inclination where it observe. So, what about this inclination? This inclination represent where? So, whether it is a theta or beta. Yeah, now it is parallel, is it? Now it is parallel. This is parallel to here. What is the angle? That angle shows what? Because we are shifted to another one, is it? We are rotating this line and shifting to that. But this true length shows, but angle showing what? If you make it parallel. So, what about the other one? That should be inclined, is it? Yeah, now we are making parallel to. What is parallel to? Horizontal inclination is parallel. So, then you have to shift it. You have to shift it in A dash B dash. So, here A dash B dash. So, there what you get as a true length, that is true inclination of with respect to horizontal plane. Yeah, similarly by looking top. So, that is the concept, okay, showing in solving of problems. Okay. Let me see the problems. Yeah, come to the problems. First problem, a line 60 mm long is parallel to vertical plane. A line 60 mm long is parallel to vertical plane and inclined 30 degree. Yeah, here the degree is not mentioned, is it? So, 30 degree to horizontal plane. The end nearer to the HP is 10 mm above HP and 15 mm in front of VP. Draw the projections of the line, that is given. So, what is a given? You have to take a straight line, that straight line having length 60 mm. So, that straight line parallel to vertical plane, but inclined to horizontal plane at 30 degree. The concept is given, location is given. One end is nearer to, you have to take either A or B. A or B you have to put it in nearer to. So, now I come to problems. Here, so I just take scale. So, what is our aim? What about the concept? I said in theory of projection, draw a reference line. The first step, draw a reference line. Draw a reference line. Draw a reference line. Draw a reference line, x, y. So, next concept. Now, we are going to the problems. In that problems, they stated length of line, location, where at location, how it is, and one end nearer to HP, one end. So, we are need two projectors for two endpoints, but here one endpoint we have to do it now. So, one end, first we have to take one end by using perpendicular scales. So, here we have to draw. We have to draw one end. Projector, this is projector. This is projector. For straight line, I am showing different colors. This is projector. So, what about one end? So, what it given here? The end nearer to HP is 10 mm, where above or below 10 mm above HP. If any dimension given to HP, HP represents elevation. So, A dash. So, 10 mm above means you have to measure above the reference line or below the reference line. So, in concept above HP means above reference line. So, now above reference line 10 mm, above reference line 10 mm. So, measure 10 mm. Measure 10 mm. Above HP, above HP means above reference line, that is A dash. A dash, A dash. So, what about next one? 10 mm above HP. Yeah, here now we are looking this problems, okay, above HP and 15 mm in front of, in front. So, what about the concept above and in front? First angle projection. So, in front of means it comes below reference line, below XY. So, below XY you have to measure 15 mm, 15 mm and mark points, 15 mm, mark points, it's A, it's A. So, now we have marked on one projectors, because in that projectors A dash, A, capital A all lies in same projectors, in that projectors, it not varying another projectors. True length is different, yeah, here. So, what about the another points? How to find out another end points? Yeah, the concept given in problems, first one, try to see here. So, 60 mm long, the length is given, the capital A and capital B is given. So, parallel to VP. So, parallel to VP means the distance not varying. So, if you look from in front, okay, no problem, but if you look from top, so parallel to VP means if you look from top, the both endpoints distance not varying from one to another. So, we have to draw a parallel to reference line, that is the concept. Yeah, here we have to draw a line, because from A, if you are looking from top, because it is parallel to vertical plane means from A to another ends, it not, A to another ends, it not varying, okay, but so what about the concept? Yeah, what is the meaning? That is why, because true length, because we are able to observe true length. What is the true length? The distance given here 60 mm. So now measure 60 mm. Now measure 60 mm. Now measure 60 mm. Yeah. Now measure 60 mm and make a point. Then draw a line. May draw a line. This is the concept. Yeah, now this is B, another point. Parallel. So parallel to vertical plane. So while looking from top, from vertical plane to this object, from A to B, the distance from reference line is not varying. That is the concept of parallel. So drawn. So I already stated. So if you mark any views of that particular point, the other views should located or placed in same projectors. So now we need to draw a projectors from this line. Draw a projectors. Draw a projectors. After drawing the projectors, now so what is the angle given? True length is given, but you cannot use true length to make intersect the projectors. If you do that, it's totally wrong, because if you looking parallel to, but it is inclined, but concept here. So what's the concept? But actually, I said is it? I think it's here. It's not to do it like that. Yeah, why I am showing here? You try to see if you looking the true length where you make it as parallel by looking top. Are you able to look this? It not, because try to see here. If you looking from top, if it is inclined, it not look. So we cannot mark B. So come to this problem, but this is actually wrong. This is actually wrong. How? That's why. Yeah, come back. That's why I do it, because we are set parallel, but true length observed by top. Yet try to imagine you place the object, this object in front of you. So inclined to horizontal plane. This is horizontal plane. This is horizontal plane. Inclined to this. Yeah, here it is inclined. But what about the true length? It is front view or looking from top. That's clear. So by looking from front only, we are able to observe the true length. So from A dash only, you have to draw a 60 mm length. So what about the angle? So therefore we have to make a projectors. You take a projectors. Yeah, from this projector. So what about the angle? 30 degree. So 30 degree we have to take. Yeah, here we are placing this projectors. So measure 30 degree. So 10, 20, 30 degree we have to measure point 30 degree. So after placing 30 degree, so we have to another ruler, because we cannot to disturb this vertical, that is and horizontal. So you have to place so placing this. So now measure, because if you keep it parallel to vertical plane, then true length of that object only from front view. If you make it parallel to vertical horizontal plane, if you make it parallel to horizontal plane, then the true length only observed from top view. That is the concept. So, that is why I shown in animation also here. So, draw a line, here draw a line. So, up to 6 mm here. Up to 6 mm, draw a line. So, after finding the point 6 mm, so this is B dash, this is B dash, and now draw your projectors. Now draw your projectors. From this point, now draw your projectors. So, this will intersect the parallel line, that will intersect the parallel line. That point is trace B, because it is apparent, it is not true length. So, this is the first problems. Problem number 1, projection. So, now projection is finished. So, after that you have to erase the extra lines, you have to erase. Extra should erase. So, I just put it break, because another problem I have to use to draw. Draw a circle, a small circle. Here there is no protractor, protractor is here, but no pro circle, because recently we are applying pro circle. It is one of the template, circular template. In the template there are number of holes. By using 6 mm hole, draw a circle, 6 mm holes, draw a circle. So, inside this circle only we have to represent problem number, print problem number 1, problem number 1. Similarly, next problems. Try to look at the second problems. What about the second problem? Here a point is given, we cannot to define A and B. So, here P, the points, here the points P is given. So, a point capital P is 20 mm above HP. Second problems. So, now we are looking second problems. So, 20 mm above HP and 25 mm in front of VP. So, first we have to draw a here that projectors, that is the reference line, the same reference line I am taken to another problem. So, now I am moving this perpendicular scale, vertical scale is it, I move on to here. We are projected is it. So, how those problems are completed? By drawing dimensions. So, it gives legible, that is why we have to draw a dimension for the previous problems by taking this here, draw a extension line. Draw a extension line. Draw a extension line on both here also here. So, then to determine the angle, and also length. So, placing perpendicular to this, because otherwise it is not legible. So, we have to draw a parallel line to this. draw a dimension line, draw a dimension line, draw a dimension line here. For angular, so we have to take a protractor and draw. So, placing, because by using protractor or that is compass or pro circle, we have to be able to draw a curve, that is part of curve. So, we have to draw a part of curve. Okay, yeah, here it not taken as, so part of curve. Okay. So, then arrowheads. So, then we have to produce arrowheads. So, already I stated the length of arrow is more than width. So, on both sides you have to draw. Here in this digital boards we are having more is it. So, I just increase the width. The given dimension should be placing. Then we have to give a letters, symbols. Here 10 mm, so you have to write 10 mm. This is 15 mm. Here you have to erase in center. Then we have to place 60 mm. All dimension are in millimeter. Then angle, so 30 degree. So, then only it completed. So, not only just projected, so after that you have to make dimensions. So, then only problems are completed. First problem is over now. Then we are moving on to the second problems. In the second problems, so a point capital P is 20 mm above HP and 25 mm in front of EP. So, we have to draw. We have to draw a, so projectors. We have to draw a projectors above and below. So, in this you have to place, so 20 mm above HP means 20 mm above reference line. So, measure 20 mm above reference line, measure 20 mm above reference line, 20 mm above reference line. So, then we have to mark, this is P dash, P dash. Then 25 mm in front of, 25 mm in front of means below xy, that is why I stated in front of, and above means first angle. So, elevation above, plan below. So, 25 mm in front of, below. So, we have to mark 25 mm, 25 mm below. So, that is P. So, then another point capital Q is 45 mm, is 45 mm, 45 mm above HP and 15 mm in front of EP. The distance between the projectors, this is important, because another point is given. So, above and below, that is with respect to planes, horizontal plane and vertical planes. But what is the distance between these two points, because projectors, because we need two projector for placing of projection, capital P and capital Q. So, one projector we are drawn. What about the other projectors? The distance between the projectors measured along xy is 40 mm. So, we have to take this horizontal scale. Please use a mini drafter scale, because in this open board I am not getting projectors, I am not getting mini drafters. Projector is there, that is a protractor is there, protractors, rulers, that is scales, these items are available, but mini drafters not available. So, instead of mini drafters I am using here horizontal scale and vertical scale. So, other scale I am using for some other directions, but in your practice you have to use mini drafters, because mini drafters having the scales horizontal and vertical in combined. So, it is very easy. So, not only that, at any moment you have to switch over at any particular angles, it is there also protractors. So, it is very simplified mechanism to use drafting. So, please use or handle mini drafter, because here it is not available, that is why I am using scales. So, that is why it takes some time. If you are using mini drafter, it is very easy to do it in particular angles. You now measure 40 mm, because in this problem the distance between the projector measured along xy is 40 mm. So, 40 mm we have to mark. So, along this another projector is passing, that is capital Q, but Q dash and Q lies in the same projectors, that is the concept here. So, what about the location with respect to planes? Try to see here. So, another point capital Q is 45 mm above HP, 45 mm above HP. So, above reference line, 45 mm, from this reference. So, 45 mm measure, that is capital Q. So, above means HP, that is with respect to HP elevation. So, Q dash. So, next, so with respect to vertical plane, because two planes, horizontal plane and vertical plane. So, 15 mm in front of VP, that is below XY, below reference line. So, measure 15 mm, measure 15 mm. So, small q. So, because with respect to VP plan, so Q. So, now we are mark the points placed on location. So, now line joining of, so P dash and Q dash, line joining of P dash and Q dash. Line joining of P dash and Q dash is a apparent or projection. So, elevation line in similar in below from P and Q. P and Q. So, now plan view, this is plan view, it gives plan view. So, now the projection is completed, a point capital P is 20 mm above HP, 25 mm in front of VP, another point capital Q is 45 mm above HP and 15 mm in front of VP. The distance between projector is 40 mm. So, determine the true length and the inclination of the line PQ. Determine the inclination and true length of line PQ. And now I take this problem is example for two method of to determine the true length and inclination. So, I just copying this. Now come. Now first go for rotating line method by using rotating line methods by using rotating line method. So, what about it is already I stated is it you have to fix one point, that point as a true point we have to refer. So, here what we have to do it. So, we have to fix capital P, that is P dash and P. We have to fix this point as fixed, we cannot change, that point is fixed, but draw a locus line. What do you mean by locus line? A line tracing or passing through that point, that is locus line. So, from P dash and P draw a locus line, that is parallel to reference line. So, draw a locus line, Similarly, from fixed point this draw a locus line. Okay. So, now take compass. Here this we have to take and placing the fixed point here and stretching over. Because here it not accommodate stretching over here. Now, we have to trace the line. So, parallel. So, from this you have to make an arc. So, here it not accommodate because due to the not flexible, okay, due to this software, that is why, because it not minimal, it minimum to some centimeter, up to 5 centimeter only it to be converge, okay, it not bring down, it not diminishing. Yeah, here. So, we have to make arc in similar, it comes here. The curves if it drawn, it comes. So, we have to draw. Yeah, do not use in paper, okay, because for explanation I do it here, but in paper no need to do it any arrow gates. You just make an arc, part of arc up to the locus line of P dash line, locus line, a line drawn from P dash that is parallel to reference line, that is called locus line. So, up to that you have to draw a part of arc. Yeah, from that draw a vertical line, from here, from that draw a vertical line, yeah, from this draw a vertical line up to that line intersect the locus line of other view, because so from which locus line we have drawn this projector from P dash, that is elevation. So, that line drawn to intersect the other view. What about plan view? So, from the plan view we have drawn already a locus line, is it that view, it to be intersect, that we have to mark it as, that we have to mark capital Q. So, fixed point capital P. So, this is rotating line method. Now, rotate line P dash Q dash by keeping P dash as constant or fixed, then rotate up to the locus line of P dash. So, then extend a line as vertical, that is perpendicular to a reference line, from that locus line to the next locus line of the plan view P. So, that intersect point is called the true point of capital Q. Now, we have made it. In similar, yeah, now we have to draw, is it? Yeah, now we have to join capital P and capital Q and denoted this. Yeah, now it to be denote. Yeah, it is here parallel, is it? But actually we are yeah. So, what I did wrong here, but it not intersect locus line, because which we are taken here Q dash, is it? How we are intersect P, how it is, because what point is this? It is the point of Q dash. So, locus line of Q only you have to intersect, sorry to say. Yeah, here, yeah, from here, because the difference, because we have to draw the line that particular point to be intersect the particular locus line, otherwise it wrong. You try to observe this, now it is able to get it not. So, draw a locus line from here Q, Q. So, then we have to draw a line. Yeah, first here this intersect point capital Q, that intersect, because the locus line from capital Q. So, that is a concept, because I started to say whenever you draw extended line from the locus line of P dash of which point you are tracing, that particular locus line of other view should intersect, that is capital Q. Yeah, after that we have to mark, try to take and draw a line. Yeah, this will gives a, sorry, I try to change over this thickness. Yeah, now measure. So, what about the measurement? It shows around 49 mm. Yeah, try to observe 49 mm. Keep it in mind, 49 mm. This capital P and capital Q. In similar case, we have to rotate small p, small q. Rotate the line small p, small q. In similar case of campus, by using campus, placing at P and rotate small q in particular distance here, is it? So, rotate here. Yeah, from this, because you have to rotate the other point up to the locus of the fixed point. So, now from P Q as the rotating line, rotate up to the P locus line, here down, okay, down. So, from this draw a projectors, it will intersect the locus line of Q dash, So, draw a projectors. So, in that projectors it intersect the locus line, that point is nothing but this point is nothing but capital Q. So, now draw line joining of these 2 points. Line joining of these 2 points. Line joining of these 2 points exactly, but this is electronic board, is it? But we cannot exactly define because due to some tolerance. So, if we are able to observe in exact picture, it shows the same dimensions below and above. So, this is the methods, we are observing. So, what about the angle? What about the angle to define? What about this angle? True angle, this is d term, true angle. What about the angle? That is why I stated here, rotating line methods where we have to observe, this rotating line methods. We are try to see if you rotate this here. So, which will we are able to obtain for true length if you rotate this particular, make it to parallel to horizontal plane. If you rotate here, it make it to horizontal plane. So, where to obtain that one? That is, we are rotate AB. Try to see here, we are rotate AB from. So, A dash B dash. So, A dash B dash is rotate to the locus line. A dash B dash is shifted, A dash is B dash is shifted and projected and fine. So, what about the angle? This is, it is inclined. So, where it obtained, A dash B dash is it? That is why we are able to understand in there. So, where it comes, what inclination it to be obtained, it confused, but it ulta is it here. What about the theta and beta, A and B, the theta is comes, A dash B dash, beta is comes, it is ulta to this, that is why I am shown here. So, P dash Q dash is it, in that PQ is d term. So, if you drawn using trapezium, that is beta. Yeah, here this angle is nothing but beta. So, this is the concept to observe true length, I think everyone understand this. So, you are able to confuse because how to obtain the true length. So, that is important, is it? So, sometimes, so we are able to understand by keeping, again I repeat, because by rotating line method, by keeping one point as fixed, that not change the other point, but you have to draw a locus line from P dash, Q dash, small p, small q, locus line, but P dash as fixed, rotate P dash and Q dash up to the locus line of P dash, then extend that point to the next point of, that is q, small q, up to that locus line, it intersect, that is capital Q in other view. So, if you join small p and that capital P, that is give true length. So, similarly, so you have to measure small p and small q as a radius, make an arc to intersect the locus line drawn from small p. So, small p, that is here. So, from that draw a projector that intersect the locus line of q dash, that intersect point is called capital Q. Now, draw the P dash and capital Q as line, that is true length. So, the above true length is represent inclination with respect to HP, the below true length inclination represent with respect to VP, that is the concept here. So, you have to write it by using this, you have to print So, draw a guideline. Draw a guideline for approximately 6 mm. Approximately 6 mm, draw a guideline. So, here we have to write it. Draw a guideline. Why I do it in 3? Because inclination with respect to HP, inclination with respect to VP, true length. For that only draw 3 guidelines. Here, so the true length, of line, so is 49 mm. I already shown 49 mm. You have to print it below the problems. Then the inclinations, the true inclinations, that is important. The true inclination, of the true inclination with respect to, otherwise with respect to horizontal plane is, that is theta is. So, we have to obtain. So, what about theta? By using pro-circle or protractor and mention here. In similar fashion, the true inclination, with respect to VP is, that is beta. So, we have to observe and write it in this. So, that is the concept for determine the true length and inclination. So, next the same problem we are looking for trapezium methods, how to determine the true length and inclination by trapezium. In this, so how to obtain by use of trapezium? So, already I stated the trapezium is a area, is it? So, A dash, B dash and capital A, capital B. So, what about small a and small a, that is small a and capital A? So, what about the distance? It is the distance of true length between A dash, is it? That is, try to see here A dash and capital A by looking top, the distance between from the reference line to which one? From the reference line to plan view, that you have to draw in A dash and B dash. So, the same concept here, we have to draw a perpendicular line. If you need to draw any trapezium, that is by use of to determine the true length, so draw a perpendicular line. Draw a perpendicular line from P dash and Q dash. In similar case, P and Q, okay, P dash and Q dash. So, what about here? P dash, that is A dash, Q dash is B dash, from P dash to capital A. So, where we are looking the distance, in front of or top of, from the top only we are able to look the distance between A dash and true point. So, try to see here. So, where is that reference line and plan view? Here. So, what about this distance? 45 mm, because that is given in problems. 45 mm, 45 mm above HP, 15 mm in front of. So, 45 mm, this is 45. Okay. So, you have to draw the dimension also. So, what I said in problem number 1, the same you have to repeat for this also. 45 mm. For this, now mark it over this perpendicular line. 45. Measure 45. Measure 45 mm and placing. So, what about the distance between the reference line and small q? 15 mm. So, that is we have to mark it over the perpendicular line of q dash, 15 mm. So, this is the trapezium methods. So, now join these two lines. Yeah, this is a true object, that is true point, capital P, capital Q. So, you have to measure the distance. Yeah, this is trapezium methods. So, what I said here, try to see in this picture. So, from A dash to capital A, from B dash to capital B is it. So, what about the angle? That is beta. It is the inclination with respect to vertical plane. So, that we have to represent here by marking. So, by marking, yeah. So, we have to rotate. So, dimensions is it. So, we have to mark this angle as beta. That is why I said in previous rotating line method. So, whatever the true length obtained, that inclination is as it is with respect to HP, but here it is with respect to VP from P dash Q dash. It is here for capital it not comes, not capital Q, only capital Q and capital P. Yeah, this is in similar. So, what about below? Yeah, draw a perpendicular line. Draw a perpendicular line. Draw a perpendicular line to this. From this point. Draw a perpendicular. Draw a perpendicular line to PQ. So, now measure this distance, that is reference line to P dash. So, what about reference line to P dash? So, here try to see this problem. So, 20 mm, 25 mm. So, just I said, so whatever the measurement in that you have to mark it over, is it. So, now 25 mm in front of VP. So, 20 mm above HP, that is we have to mark it here. So, this is 25 mm, is it. We are wrongly made it in above 45, is it, that is 25 mm. This is 25 mm. Yeah, here 20 mm you have to measure, this is 20 mm, this is 20 mm, this is 25 mm. So, we have to draw in this. Now, we have to take the scale and measure 20 mm. 20 mm, measure 20 mm. Measure 20 mm. So, what about in Q dash? So, Q dash 45 mm, yeah, here only it's 45 mm. So, now measure 45 mm in this. So, now change over this and drawn. Yeah, capital P, capital Q. So, here it is 45 mm, this is 45 mm, yeah, this is 25 mm. So, after finding, then similar what I said in the previous for rotating line method, draw a line. So, here you have to measure the angle between this is d term. So, theta with respect to HP, beta with respect to VP. Then you have to measure capital Q and this and obtain. Yeah, here it did it wrong, is it? That is why I erase and redo it this. Because only 25 mm it comes there. $25 yeah, capital Q, that is, what about the distance of 45 mm above HP, 15 mm. So, here 15 mm is it, 15 mm, that measurements it gives 15 mm. Yeah. Yeah, this is 15 mm, is it? 0 here. Now, draw a line. Draw a line. Yeah, this will gives true length. So, that is the concept, is it? Yeah, now this projections, the inclinations gives beta m. By this way only we are able to obtain the true length and true inclinations. So, below you have to draw a guideline and printed the true length of line is and the true inclination of with respect to horizontal plane theta is, the true inclination of with respect to vertical plane beta is. So, what values comes you have to write it, that is print. So, that is concept in project, the projection of point straight lines here. Yeah, many problems are there, is it? So, in single session we are not able to complete all. So, further we go for another session to make it the remaining problems, because today in the sessions we are covered the basic things in projection of straight lines, and two problems you are learned. So, the first one is projection, the second one is how to find out the true length and the true inclinations in two methods, one is rotating line method, another one is trapezium methods. Then the remaining three problems we are looked in forthcoming sessions. So, with this I complete now. Thank you.